Math Blast 13. I can identify prime and composite numbers. Look at the numbers below. Shade each number that is prime. It's important here that we know what a prime number is. A prime number is a number that has exactly two factors, 1 and the number itself. So for this task, we just need to identify a third factor in order to say the number is not prime, but instead is composite. So 66 has factors of 1 and 66. If those were the only two factors, we would call that number prime. However, I know that since it's an even number, it also has a factor of 2. And so just by identifying that third factor there, we can say that 66 has to be a composite number. 60. 1 and 60 are factors of 60. But ending in a 0, I can say I know that 10 is also a factor of 60, making it a composite number. Now keep in mind there are other factors as well, but I only have to identify that third factor to call the number composite. 30. 1 and 30 are factors, but again, it ends in a 0, and so I know 10 has to also be a factor of 30. 99. 1 and 99 are factors, but 9 is also a factor. 9 times 11 would give me 99. 23. 1 and 23 are factors. And those are the only two factors. So that's a prime number. We're going to shade the box. 11. 1 and 11 are the only two factors, making 11 a prime number as well. We'll shade that box also. Fill in the chart below with 4 different composite numbers that are between 30 and 40. Again, a composite number is a number that has more than 2 factors. So I'm going to choose numbers that are even because I know that any number greater than 2 that's even is going to be a composite number because that number would have 1 and itself as factors, but also 2 since it's even. So we're going to go with 32, 34, 36, and 38. Now those are not the only options here. Those are just the even options that I'm choosing for this round. I can add and subtract multi-digit numbers. Find the sum. Sum is the answer to an addition problem of 791,025 and 194,641. Well, I'm going to add the two numbers, and while I write these two numbers in a vertical form, I'm going to line up the place values so that I can add like units. Ones to ones, tens to tens, hundreds to hundreds, and so on. So I have 6 ones, 6 tens, 6 hundreds, 5 thousands, 18 10,000s. I'll leave 8 of the 10,000s. I'll bundle 10 of those 10,000s and make it into a greater unit of 100,000. And now I'm left with 900,000s. So my sum is 985,666. Find the difference. The difference is the answer to a subtraction problem. So we're going to subtract the two given numbers, 870,362 and 471,972. Again, I'm making sure that I lined up my place values so that I can subtract like units. 2 ones minus 2 ones is 0 ones. 6 tens minus 7 tens. I don't start with enough tens to take 7 tens away right here. So I'm going to go over and rename one of the hundreds. I'll leave 2 hundreds. One of those hundreds is going to become 10 tens. With the 6 that's already there, makes that 16 tens. Minus 7 tens is 9 tens. I start with 2 hundreds. I want to take 9 hundreds away. We're not going to do that right now. We're going to go over and regroup. There's no thousands. So I'm going to go into the 10,000s place. It leaves me 6 10,000s. Let's one of those 10,000s become 10,000s in the thousands place. So I now have enough thousands. I can make one of those become 10 hundreds with the 2 that's already there, and that's why I have 12 hundreds. Minus 9 hundreds is 3 hundreds. 9 of my thousands minus 1,000 there is 8 thousands. In the 10 thousands place, I start with 6. I want to take 7 of those away. So I'm going to go over and I'm going to regroup. I'm going to take one of the 100,000s, leaving 7. The one that I'm going to take, I'm going to unbundle into 10 10,000s with the 6 that's already there, and that's why that's 16. 16 10,000s minus 7 10,000s is 9 10,000s, and 700,000s minus 400,000s is 300,000s. So the difference, the answer to the subtraction problem here is 398,390. I can divide a 4-digit dividend by 1-digit divisor. Solve using any strategy. 1,425 divided by 3. Here, I'm going to use the place value strategy. I'm going to have ones, tens, hundreds, thousands. I'm going to model my dividend 1,000, 4 hundreds, 2 tens, and 5 ones. Now I want to divide by 3. So I'm going to make bundles of 3. I don't have enough in the thousands. I'm going to unbundle that here, which makes 10 hundreds. And now I will make bundles of 3. There's 1, 2, 3, 4 bundles of 3 is what I was able to make. These 2 here are going to come over and make 10 tens each. So each one of those hundreds is going to make 10 tens. And now I will make bundles of 3. There's 1, 2, 3, 4, 5, 6, 7. 7 bundles of 3 is what we were able to make. This one that was left over is going to come over here and make 10 ones. So that 1 10 we had left over unbundles into 10 ones. We will now make bundles of 3 once again. I was able to make 5 bundles of 3. And so the quotient, the answer to the division problem, is equal to 475. On the back side, I can interpret data in graphs, create graphs, bar, picture, line, plots. Students' favorite color. Here we have a bar graph. We want to know how many more students' favorite color is blue than black. So looking at blue, I see that there are 15 students whose favorite color is blue. For black, there are 5 students whose favorite color is black. And so 15 minus 5 is 10. 10 more students have a favorite color of blue than black. For the line plot, pieces of ribbon were measured to the nearest 1/8 inch. The measurements are listed below. Make a line plot representing the data. So I see that I have 1 1/2. I'm going to look at my data set here. The smallest number I have in my set is 1 1/2. The largest number I have in the set there is 3. So I'm going to go from 1 to 3. Looking at my whole numbers, I'm going to go 1 to 3. I know right in the middle of that is 2. And then I see that I have halves. So I'm going to go 1 1/2. And here I would go 2 1/2. I'm going to put an X above the number every time it is represented in the data set. So here I have 1 1/2, 1 1/2, 3, 2 1/2, 1 1/2, 2, and 1 1/2. What is the difference between the longest and shortest pieces of ribbon? Well, the longest piece of ribbon would be the piece of ribbon that measured the longest in length the most, so that's 3 inches right here. And the shortest piece of ribbon would be the one that measured the shortest. Now, it's not going to be 1 inch, although that's on our line plot. We have no X's above that. So it's going to be one of these 1 1/2 inch measurements. So, whoops, what did I do there? 1 1/2. We're going to clean that up real quick. 1 1/2 inch. And so we now can subtract. 3 inches I know is the same thing as 2 and 2/2, because 2/2 makes another whole. But that allows me to take that 1 1/2 away. So looking at the whole numbers, 2 minus 1 is 1, and 2/2 minus 1/2 is 1/2. So the difference is 1 1/2 inch. I can classify triangles by sides and angles. Identify the triangle by sides and angles. So in terms of sides, an equilateral triangle has all equal sides. An isosceles triangle has at least 2 equal sides. And a scalene triangle has no equal sides. And I can see these markings here tell me these 2 sides are equal. So this is going to be an isosceles triangle. In terms of angles, a right triangle has a right angle. That means it has an angle that measures exactly 90 degrees. An acute triangle has all acute angles, all angles that are less than 90 degrees, which is what I see here in this triangle. All of my angles are less than 90 degrees, so it's going to be an acute triangle. An obtuse triangle would have an obtuse angle, meaning it has one of the angles that measures more than 90 degrees, but less than 180 degrees. So, specific name for our triangle is an isosceles acute triangle. That's all for today, math friends.